Good morning. Good morning, everyone, and thank you for attending this conference at ITBN conference. I'm actually glad that we're here today, and I want to start with some good news. We get to hear every single day about how dramatic the news are, whether it's about the weather forecast, or whether it's about cyber concerns and cyber threats and cyber attacks. And sometimes we tend to forget the true world we live in. We live actually in a world that is actually fascinating when you really step back and look at the major trends. We live longer than ever. Every single year, we live 3 months more. This is almost exponential. The living standards have never been that high. If you compare that to years ago, it's fascinating. Education gets better and better. The world's population has never been that educated. We managed to flip it around. And we're increasingly concerned about environmental issues, but when you really look at the macro data, you realize that even the ozone layer is actually, to some degree, healing. So there are fantastic things happening in this world. And I guess the question is, why is this happening? And why is it accelerating? Why does it get faster and higher than ever? And part of the answer lands with exponential growth technologies. Those technologies that actually are fueling today's world in terms of research, in terms of everyone's daily life. And this is what I want to talk about. I want to talk about the impact of exponential growth on ourselves, and I'll apply that to cybersecurity and how that impacts the future of cybersecurity. And of course, exponential growth is not something that we're used to as human beings. The way we think, the way we shape, the way our brain works is very linear. And therefore, the way we tend to look at things and to predict the future is also very linear, while in reality, a lot of what's happening is no longer linear, it's exponential, which means that it gets us higher and faster than we think. Let me take an example of what I mean by linear versus exponential. If I'm walking and I'm doing 30 steps, each step is 1 meter, what does that get me? 30 steps, 1 meter each, how many meters would I have achieved? Anyone? Simple math, 30 meters, you're absolutely correct. That's the way we work, very linear. Now think about what that would be if every single step was meant to be an exponential step. I start with the very first step being 1 meter, but then it's no longer another meter, it's exponential. I'm still doing 30 steps. How much would I have achieved? 30 meters? No. Any idea? That's where we need to do advanced calculation, because that lets us to achieve more than 26 times around the globe. 30 steps, but exponential versus linear. Nothing that we have in our brain. It's always a bit provocative when you do the math and you do the calculation, right? And this is exactly what's happening to us. What's happening to us is that very important technologies shaping the cyber world, the digital era, are actually fueled by these exponential fundamentals. Murphy's Law that was mentioned in the previous session is a perfect example in terms of processing power that we get available to us for whatever we do in daily life. In the past 40 years, we've increased it over 100 billion times. This is fascinating. Not only the power we get, but the cost of this power, which is a fraction of what it used to cost, right? So this is obviously fueling the innovation, fueling the way we do things. And no surprise that this Apple Watch is actually more powerful than 2 of the largest supercomputers that I could get as a teenager. And by the way, I couldn't get it because it was so expensive, right? That's the transformation that we're going through, fueled by exponential technology. Another example of exponential growth is how many people are connected over the internet. Would be close to 5 billion people in 3 years from now, that we'll all be connected over the internet. Think of what this means in terms of minds that get connected, that get to share, that get to create, that get to innovate. It's fascinating. And the impact is huge. Think of the way we develop applications and provisions and deliver applications, which nowadays we tend to call apps, to our users. What used to take 9 months 4 years ago, to 2 days 2 years ago, takes 6 hours nowadays, thanks to innovation such as DevOps and agile technology developments, processes, and lean management, and other things. So it's truly impacting the way things are being shaped. Look at the infrastructure around us, the cloud, the Internet of Things that was just mentioned previously, the virtualization and how this impacts today's computing, as well as mobile. This is also part of this exponential technology that is reshaping the future. And they all share one thing in common, which is the security concern. Security always comes first in terms of what we see as a challenge looking ahead. And for very good reasons. We tend to see more and more about those threats affecting our daily life. It's no longer technology matters for security experts. It's affecting all of us. Getting electricity, getting actually to healthcare service. Think of WannaCry and the impact to the NHS in the UK a few months ago. So those exponential technologies are just fantastic and impacting dramatically our life, but we need to be fully aware of how important and how critical cybersecurity is becoming to all of us. And the question is, what's the future of cybersecurity? How exponential technology can help not only impact the innovation in the digital era, but also the innovation in terms of how we secure that digital era. Think of how the security industry has been doing so far. It's mainly been very reactive. There's been viruses, and therefore there's been antivirus vendors, right? And then there's been malicious websites that people connected to, and that created an opportunity for URL filtering solutions. And then there's been intrusions affecting information systems, and there's been intrusion detection systems, which were slightly improved to be intrusion prevention systems in the very base case, and so on and so forth. So by design, the security approach has been, for years, almost decades now, very reactive, right? And it's no surprise that being reactive in the way it was shaped, it was thought, it's therefore very often, too often, one step behind. It actually is able to capture known attacks, the attacks of yesterday. But increasingly challenging it is to deal with not the attacks of the future, but the attacks of today, which for many of them are not known and increasingly difficult to predict. So it's becoming a challenge. And looking forward, exponential technology and artificial intelligence and machine learning is definitely significantly impacting the future of cybersecurity. I want to touch that with 3 key pillars of how we could predict cybersecurity to look like in the coming years. The number one thing is the security effectiveness of what we do, right? How effective is security? Well, some people would argue that's actually challenging to measure. Maybe not. Maybe security effectiveness should be extremely simple. Just stop the threats, stop the attacks, prevent the breaches from happening. You could make it as simple as that. It's obviously challenging to make it a reality, because when you look at what's happening today in the IT systems, including for high-profile organizations, public or private, you realize that we're not there. Many organizations, in average, it takes them about 5 months to realize that they've been breached. 2 times out of 3, they don't even find it out by themselves. It's a third party notifying them they've been breached 6 months ago, 1 year ago, 2 years ago, for billions of records that leaked and in the meantime have been used. So we could actually pretty much agree that the effectiveness of security is not where we would like it to be. Where we would like it to be is to have security effectiveness in the sense of preventing the attacks before they occur, of having ways to make sure that they are blocked prior to damaging our systems, that the ransomware campaigns are somehow not impacting the daily life of our users. How could that happen? Machine learning and artificial intelligence is significantly reshaping the future of cybersecurity. I would actually probably even say today's cybersecurity solutions, as there is an increasing trend to leverage those exponential technology to do better, to be smarter at how things go. If you combine the amount of data that we're able to collect with big data, for instance, and you put on top some smart algorithms that are more mature in terms of machine learning, and you combine that with almost unlimited processing power that you get, thanks to Murphy's Law, and combined with the power of the cloud, you realize that there is a lot of effectiveness that you can get in real time, not only about dealing with known attacks that have been hitting us for years, but also dealing with the unknown, trying to predict the future. And how do you predict the future? You predict the future by learning on the past, but also learning in real time on the present. And learning in real time means that we need to be extremely agile, extremely smart about it. For too many years, there's been either a focus on being very precise on blocking attacks, mainly known attacks, with signature-based type of approach, looking at the fingerprint of an attack with a hash, which is extremely precise, but it's so precise that it's so easy, so trivial to evade for a hacker. On the other hand, there's been for years technologies around, including anomaly detections and looking at behavior of traffic patterns, which has been extremely interesting to look at, but very ineffective in terms of accuracy, creating so many false positives that it was very challenging to turn that into preventing things from happening. And artificial intelligence, together with machine learning more specifically, is actually reshaping this dilemma and allowing all of us to actually increase the confidence we have in the detection capabilities, in the understanding of what's going on in our systems, on our IoTs, on our mobile devices, on our networks, in the cloud. And because we have increased confidence in what we see, what we understand, we are therefore more willing to not only detect, but prevent. And because we can do that in real time, the security effectiveness is no longer about having those data breaches going on for months, but is actually getting us towards the future where you actually can prevent things from happening in real time rather than after the attack, right? So security needs to be effective, and technology and exponential technology is actually making it significantly more effective. But security needs also to apply everywhere. And why everywhere? Because attacks are coming from anywhere. Think of the latest attacks that you've heard about. It's either a USB port that was available to plug in and inject some malicious content, or it was a mobile device that got infected, and from that entry point, it spread all across. Or it was an email that had an attachment that was a malicious PDF file. Or it was actually an SMS doing phishing with a short link that got you infected without you knowing about it, creating a data breach for months until it's discovered. Or it was IoT devices, like air conditioning systems. We keep learning that the surface of the attacks keep increasing, and therefore security needs to take that into account. Security needs to be everywhere. And what that means is that it's not so much about technology only, it's not so much about a point product only, but it's definitely much more of an architecture play. Looking forward, what you want to care about is how you design security, how you envision to architect it, as opposed to only the technology aspects of things. And looking at on architecture, you probably want to make sure that you embrace a lot of enforcement points, as many as possible, physical devices, as well as virtualized devices, endpoints, traditional endpoints, but also new generation of endpoints, such as mobile devices and tablets, phablets. You want to make sure that you also embrace network security systems. As we've heard previously, sometimes that's the only option available to you, is to enforce security at a network level, since you can't do it on the device itself, whether it's a car or an IoT device. So the ability to enforce security everywhere needs to go hand by hand with the ability to actually combine that with centralized management capabilities, the ability to actually not only enforce security policies all across, but also to collect in real time indicators, data that you can process so that you better understand the security posture of your environments, the attack vectors that are being used, and manage to defeat that in real time. So we've talked about security effectiveness, we've talked about security being everywhere. And the third pillar and last pillar is efficient security. Efficient security means that we need to think of how to do that differently than we've been doing it so far collectively. And if you look at the hard trends, they're tough with us, right? We keep spending more collectively on IT security spendings. We spend more every single year. And still, the problem is that we're not getting the results that we would be hoping for. Our trust in our systems, users' trust in their systems, consumers' trust when they do online surfing and purchasing and banking has never been that low and keeps declining. It declined by 25% in the past 3 years. So we spend more to build trust, and as an outcome, we get less trust. More breaches, more security issues. Something is wrong. And exponential technology will help us address that, but it's not just the technology itself. It's also the way we think, the way we architect, the way we design. Too often, we end up having security systems that are extremely fragmented, very complex, very advanced for sure in the lab, but very complex in real time, very monolithic, that don't share intelligence, that don't share effectiveness, that are hard to manage. And to some degree, part of the question is, are we solving an issue, or are we making it even worse, actually? And it's very clear that we need to think differently, that we need to consolidate a lot of this complexity to simplify it. Because if you don't consolidate, you keep increasing complexity, you keep increasing cost, and you keep declining on the confidence that you have in the overall security of your systems. So simplifying by consolidation, and what do I mean by that? I mean two things. One is simplicity. As human beings, we can only manage things that we understand. When it gets too complex, we don't fully understand it anymore, and therefore we don't fully manage it anymore. So we need to simplify this. Simplifying means two things. One is for sure trying to consolidate things, security controls. Doesn't mean less security controls, probably more security controls, but more consolidated, right? Well thought, more efficient. And it also means thinking about architecture. One footprint, one architecture. That requires agility for sure, but that is architect somehow. Architect and security sometimes doesn't get along so well, culturally, right? So consolidation to simplify the systems and relying on a single infrastructure and a single architecture is where probably the future gets us to. And last, is to think of how security will be in the future. Security will be even more important than it is today, because cybersecurity will be about everyone's life and how to protect our life. We talked about automation for cars that are becoming autonomous cars, and you understand the impact are no longer about systems being corrupted or unavailable. It's about humans' life, right? So we need to make sure that security is scalable enough to handle with those future challenges, and that means that exponential technologies such as big data, such as artificial intelligence, such as deep learning, machine learning, needs all to be combined to help fuel this intelligence and this effectiveness of cybersecurity with more automation, as we want to have real-time prevention without having security administrators having to decide on what needs to be done for specific traffic that is getting into our systems. We also need to have platforms to share intelligence, to share indicators of compromises, to make sure that those data are shared, digested in real time, to create new protections that you can apply in real time, meaning that needs to be automated. And last, we need to think of security that scales also in terms of performance. Many of the systems that we need to secure are no longer going to be systems that can embed security into them. The example of the toaster is a perfect example. Do you think of injecting security in a toaster? Do you think of injecting security in this watch? It's going to be limited, right? Either because of computing power or hardware resources, and probably also because of battery lifetime, right? Which is something we all need to deal with. So we need to make sure that the security platform, the security architecture of tomorrow is actually something that can help you offload some of the security processing somewhere else than on the device itself that you're trying to secure. Right? So floating security will help get better security and dealing with the requirements in terms of performance. Right? So with those three pillars, I would like to leave it to your brain to think about it and think about it in an exponential way. Thank you very much.